All right. Good morning. Well, still a minute before, but Mike, I'll go ahead and get started. I think I'm still having audio issues for my attempt to live stream here. I don't know why. So anybody that's joining this after the fact, or I don't think I got anybody right now on the live stream, but I'll continue working on that. It's annoying because there's some stutter, and it seems to work when I test it out other places, but when I come to this room, for some reason, I'm getting some audio issues. So let's try some different hardware, maybe, or something like that, I guess. Okay, so let's go ahead and get started with stuff for today anyway. So yeah, my plan was I'm going to continue where we left off, so I can start and see if anybody had any questions they want to ask about the specifics for the assignment one. So let me go and bring up the assignment. I'm probably going to just quickly go through some of the stuff maybe we did on Tuesday, but also maybe look specifically at each one of the tasks you're supposed to do for the assignment, and see if anybody, at least that's here, has any questions on things. So like I showed before, let me just remind you of a couple things. I'm just going to go ahead and reopen up my assignment that I wanted to work on, which I think is this one. For me, yeah, probably. You should have it reopen a container. I've had a couple people asking, you don't technically need the containers. You can have a Python distribution of your own. You could be using other Git software or Git GUI to do the clones and create your commits and get them pushed on there. The containers are there just as a reference for the versions of the libraries and stuff. So I did mention this last time that if you're not using a container and there's incompatibility issues, it'll be on your shoulders to debug it, to figure out what the incompatibility is and get your own environment set up so it's using the same libraries and stuff that we did on here. So there is, I also haven't had a chance to check out whether this is going to cause an issue when you make a commit. I think I will go ahead and show that in case anybody needs an example of how you actually submit something up for me to see it and have it evaluated. So, but yeah, as a reminder, I did screw up the Python path on this assignment here. So, you can fix that locally by just setting your Python path, or I'm gonna give an example of recreating my container. So I really want my Python path to be that workspace is this directory name /source, because that's where the files that we're going to do imports from are in the source subdirectory here. I mean, basically all your work pretty much goes in the assignment tasks for these assignments, right? And you could set that by hand, so you could do stuff from the command line, or like I showed before, this is actually part of the setup of your Docker containers, the dev containers, as VS Code calls it. So yeah, I'd set it there. If you set the path the way you want it, you can recreate the container. This probably puts this out in some file inside the container on your etc directory or something like that. I'm just going to delete my container and recreate it, which is another thing which is might be useful for people to know how to do, right? So I had already set that, but I hadn't recreated my container. So when I restarted the container, my Python path was still incorrect. So if we go ahead and close this container back off, so a close remote connection is how you cleanly shut down container. And again, you could use other tools to manage these Docker containers, like the Docker desktop, but I'll use the remote explorer, which is installed by having the dev containers extension installed in VS Code here. And I'll just go ahead and delete my assignment one container so I can recreate it. So it should use that correction of the Python path when I recreate my container from scratch here. So let's just reopen that folder up. after I deleted the container, since there's no container anymore, it should recreate the container. Oh, that went really quick. Hopefully that worked. Oh no, it's still going. So yeah, if I hadn't deleted the container, it wouldn't be doing these steps again. I mean, this is where it's doing those things that's in that Docker file in the devcontainer.json file. So it's doing some apt update, so it's updating all the software on the inside of the container and doing some other stuff here. But yeah, it shouldn't take too long, but let me go ahead and let that keep running here. Let me also get my repository back up. So like I showed, I usually go to my organizations if I need to get back to a repository in one of these organizations for these assignments. So over to your GitHub settings, find your organizations, find your particular organization, which for most of you probably won't have as many as I've got set up right now, but it should be the 574 Spring 2026 one. And then look at your repository. You should be able to find it there. Okay. So anyway, I'm back to my container. Let's look at my pull request. So yeah, I didn't show an example of creating a commit and pushing it up there. So yeah, while this is going here, let me see if so it was. I had a couple questions already. Well, I mean, not already. Some people working on the assignment. So yeah. So one of the ones at the near the end, you have to do a couple of loss functions. So in this class, we will talk about, when we get to talk about linear and logistic regression, we're going to go into some details of how those are actually implemented a bit. So one of the important things is this one's a loss function. So you're supposed to do the root mean squared error and the mean absolute error. I think were two of the ones for the very last task for this assignment. So yeah, the root mean squared error, I think, is supposed to be the square root of the mean squared error. Somebody asked about that. So the description wasn't completely correct. But for all of these, of course, the final arbitrator is the test that I give for each one of the tasks. So I think I'm right. But if you implement it as the square root of the mean squared error, and it's not passing the tests, then maybe it's the other one. So you do need to get it. So what I'm saying is that you do need to get it so it actually passed the tests that are given. And I was going to show a little bit more of that here once I get my container created back up as well. I touched on those tests and where they're run from a little bit on Tuesday. I'll give some more details about how all that stuff is. So while I'm kind of waiting on this, does anybody want to ask something else maybe about the assignment?
And do we need to merge the pull request?
You shouldn't have to do any merges, so you should be doing all of your. Leave that pull request open and don't merge it or close it. So, like it says here, don't close that or merge this pull request here. So, the way the GitHub Classroom is set up is it's expecting you to put all of your commits just onto the main branch and then push them up onto the main branch here. And then this feedback pull request should be showing everything you push onto the main branch. But yeah, just leave this open and unmerged. That gives me the most information in terms of being able to find the auto grader results of the last commit that you pushed and other stuff. take longer than I thought. So, well, I could bring. Let me just go. I can scroll through the notebook, and we can start discussing these at least while I'm waiting on my container to be recreated again. So yeah, just you can always kind of look through your source on your GitHub repositories, and GitHub is kind of pretty good about being able to, for example, I mean, this is actually a JSON file, these IPython notebooks, but it does render it kind of, at least the last save that you did of your IPython notebook. Although, yeah, doesn't get everything, like it doesn't get links to some figures and stuff when you do it this way. So, if I have some time, I was going to maybe also talk a little bit about NumPy and scikit-learn, maybe just general stuff. Also, some things about using notebooks here today. So, if it wasn't clear, the first task we were trying to give you some ideas about the difference between vectorized and non-vectorized code. So you were supposed to write this first function not using the NumPy library, so just using the non-vectorized version. So basically the exponential function from the standard math library in Python only accepts scalar values. You can't give it like an array or a list of values. So by scale, I mean a single value. So if you give it a single value, it'll return the exponential of that value. That's pretty much all it does, as opposed to like the NumPy version, which is vectorized, which is meant to be used where you pass in like a NumPy array, and it will give you the exponential on a whole array of values. Right? And if you've read the notebook on NumPy and vectorization, it's a performance thing here. So NumPy vectorized operations will perform much faster on arrays and matrices of values than a non-vectorized version. Because as a first approximation, you can think of it, when you're not vectorized, you have to write like a loop. So if I want to do the exponential on a list or an array of values, I'm going to do them in a loop one by one. Whereas vectorized ones do some parallelism. Effectively, so in different ways, but they can compute arrays and matrices operations much faster than what you would get for a non-vectorized version, where you're essentially kind of looping through and doing them one by one. So anyway, I mean, that was kind of what the basic sigmoid was supposed to be, but then you were supposed to implement a vectorized version for the second task. For the sigmoid. So the one instead called basic sigmoid, just go ahead and use the so, and this one is expecting that you can pass in arrays and it will work. All right. Okay, so I got my container back up. So let me see if that worked there. So remember, I was trying to fix my my path there permanently instead of having to do it by hand every time. So now that I did that, I should have it set up like that, and this will allow me to do things like run my tests from the command line, which will be failing at this point, so I don't have any of them working, but it's able to actually find the stuff and run it. All right, so anyway, yeah, I mean, that's kind of where that's coming from. And since I have that set, I shouldn't have to. Let me also remind you about so we are forwarding, we are actually running a Jupyter Lab server, so you can run the notebooks inside of VS Code. It has the ability to do that, or you can run them from a web browser using the Jupyter Lab server. This is maybe a personal preference. I usually do like running notebooks from the web-based server, although I like editing stuff. So if I'm actually doing lots of edits on files, go back to VS Code to do my actual editing for things. So in this case, remember, if you just go to that port, if I control click on that, you do have to give a token. So the only way you actually can see that token on the output. So like if you look at no, I'm wrong. Yeah, so it puts it out to this file here. So I guess you can't really see it. You have to go find this file to see the token that's generated each time. So I also fixed this. So later on, you won't have to do this. You can just do a setting so it doesn't generate a token. It just is open, which I should go ahead and put that in here. So because we don't really need to have this kind of password token for this kind of a setup here. But anyway, if you find this, you can control click on that link or just copy paste that token to get into your web-based Jupyter Lab server here. All right, and since I fixed my path, I shouldn't have to do this anymore. Let's check if that's working. There, yeah. So with your path set correctly, I mean that Python path, it's set in the container, but that same Python path is being used in this Jupyter Lab server that's running here. So since it's correct, we don't have to do anything special to get the path set up. So yeah, I had the last thing we'd done last time was, although I didn't make a commit, but we showed how these tests work and how modifying these files does things. So if we look at our assignment tasks, I had hard coded it so it would be passing like for 0 and 3, right? So I've actually got some modifications locally here, so I should be able to run this cell as well. And not everything is passing, but I'm passing the 0 and the 3. I could probably get all these tests to pass. I'll show you what it looks like if you get everything passing. So for the -5, so if we look at the test assignment tasks, there's one final one where we're expecting this result if you ask for the basic sigmoid of -5 value. So if I add that finally in, so if I add that in, I probably should be passing all my tests when I run them here. Let's see if that's true. Still missing one. So I'm passing the 0, 3, -5. So on this one, we are expecting that if we pass in an array, an exception will happen. So it'll raise a type error. Because I think I did have a question, or at least I've had a question in the past on the same one. I'm basically hard coding and expecting you to do the simplest thing possible here. So I'm not usually expecting you to do a lot of defensive programming for the assignment tasks. I'm just expecting you to directly call the math.exp function, which will raise an error here usually. So here, if it's none of these, I'll just raise, I think that's the right syntax. I can't remember the syntax on Python for raising exceptions. Let's see if that works. That's probably not the right. Oh, yeah, in this case, I'm getting an exception before I get down to the end there. Uh, so look, you if you haven't done stuff with this, as you kind of work with these, you'll get better at understanding, be able to read what the problems are, right? So basically, this one's failing here because it tries to compare an array to a scalar value there. Because for this test, we're passing in an array. So we're trying to pass in a NumPy array of values. But I've got some code in there that tries to compare whatever we pass in. So we're not doing any type checking right now. So anyway, yeah, and that's illegal. We can't say is some array equal to some particular value. I'm not gonna fix that. So, but once you implement the function correctly, you should see everything passing, and you shouldn't get any error output here. All right, so you should see no failures. Okay. So if I did have this finished, so the way that you submit stuff is you have to make a commit and push it back up to GitHub. Right. So again, you could use other Git tools, but if you got the setup that we recommend for this class, you can go to VS Code, use the source control. This is quite nice. So you can actually use this to see the changes you've made so far. So, for example, if I click on my assignment tasks, we get a diff, right? So right now, in my last commit in the repository, that was the code that was in there. My current uncommitted work is the green stuff here, right? So I want to make a commit where I add these changes in and then push that back up to be graded. Although I don't think that, well, yeah, so I can do diffs on IPython notebooks, but really IPython notebooks are the JSON files, so these diffs probably won't be as useful, or they'll be messier to understand because you have a bunch of stuff in there. Another thing, when you make a commit, do be aware of, only commit the stuff of the changes that you want here. So I've got some changes like, like I fixed my Docker file here, but I don't really want this commit here. And I created another notebook. I was showing an example, but I really don't want those part of the commits. My commit that I want is my changes in assignment tasks and my notebook that's running those to actually be in this commit and pushed back up there. Right. So this is called staging. You should only stage the files that you actually want to be in your commit. You don't have to stage everything. Or you should definitely be aware if I'm doing some other work that shouldn't be part of the commit. I'm not adding that into the commit, not staging it. So yeah, I just want to stage this one and those two, yeah. My notebook and my assignment tasks. Another thing, I probably discuss it in like the instructions and stuff, but I do ask that all these tasks be in a separate commit. This helps me get an idea of what you're doing, so your thought process as you're working on the assignments and things, right? So it's incorrect to have just one commit where all three tasks for this notebook are given here. So, technically, like subtasks are fine, although maybe for practice, for the first one, if you haven't, I might be a little bit too late for some people, but which is okay. I probably won't be too picky about it for this first assignment, but going forward, things that are like big tasks, task 1 and 2, at least need to be a separate commit. So I was looking for at least 2 commits for this first assignment. Although, it might be a good idea for practicing to do each one of these one by one. So we have like 5 separate task commits for task 1, where you commit the working version of each of the 5 functions you're supposed to do, and then another 2 for task 2 or something like that. All right. Also, try and give good commit messages. A basic commit message always has a title. Followed by some description. So the description should be full English sentences, or be at least one sentence or more. There's lots of, again, I won't be too picky about this, but at least get into the habit of having a title and some description of each of your commits that gives me some idea of what is in the commit. So we hard coded the basic sigmoid to pass 0, 3, and -5. Right. So the difference between the title and the full description is just a blank line should separate the title and the full description. So when we create a commit, that didn't always used to have this graph on VS Code, but you can kind of see a history of the commits that have been happening so far. So basically, I got this commit locally that I haven't pushed yet. So this was the last commit that I pulled down. Another thing, if you're not used to working with VS Code, sometimes it'll tell you that you've got local changes and give you a option to synchronize. Sometimes you don't see it. I'm not certain why you see that in some cases and not in others. It might have to do with if you still have local changes that haven't been committed or not, whether you get that synchronized message. Not certain. But anyway, so being aware of the status information down here. So this is telling me on the lower. So there's a bunch of useful stuff to get to know, be familiar with. But this is telling me for my Git status, my revision source control status, that I'm on the main branch. I've got no commits on my remote repository that I haven't pulled down yet. So that's what the 0 with the down arrow means. But I've got one commit locally that's only local. It hasn't been pushed back up. It needs to be synchronized to get back. So I can't see this work yet. So if you've done this and made a commit but haven't pushed it back, I can't actually see it and grade it. So you can actually click on that to do the push or the synchronize. And you should be able to do the same thing here, although individually. So this is like a pull or a fetch, a pull and then or a push. These things here. So I'll go ahead and push that back up. So only after I've done that will go back to my repository here. Sorry, my repository. So if we go back to our feedback pull request, I should now see the commit there with the, so you'll only see the title unless you should expand now. I don't know why it's not being responsive here. Probably because, and also the auto grader, the GitHub Actions are still running here. So let's see if those actually work or not. It's another thing I haven't really checked yet. There it goes. But yeah, so that's the difference. So normally you only see the titles, but if I need more information, expand that out and see a bigger description of what was done there. So. Also, the same tests that are run in the notebooks are run here in the auto grader, but I mean sometimes you might think things are working or things are working when you do them on your own system, but when you push them back up, there's issues. So you probably should always go and check what the auto grader is saying about stuff here as well. So you can view the details of this. This does take some time because, in fact, I mean, I'm surprised GitHub allows this for free, but this is doing the same thing as the Docker container. So it will actually install the same Linux environment, so like a basic Debian environment. It will install the Anaconda installer, and then it will use the environment.yml file to install exactly the set of Python packages before it runs stuff. But this actually takes 5 or 10 minutes, so it's actually still doing it. Yeah, so it actually had gotten to, was trying to see if the notebook is running cleanly. And my notebook is not running cleanly here. Uh, yeah, so let me mention that. So I do want notebooks to run cleanly. And I guess that I thought it was, but it's not. So what I mean by that is the usual way that if you're not used to working with IPython notebooks is most people expect that the notebook is run, each cell that you define that has Python code should be run sequentially from the top to the bottom of the notebook. It's not valid to define things like in a cell at the bottom, expecting that cell to be run before you go back and run a cell above it, right? So notebooks are essentially sequential, like you're reading a book. Notebooks are supposed to be meant like self-documenting code, so you can combine descriptions along with code that's meant to be run and kept up to date. All right. So that means that you should always be able to, if I do a kernel restart kernel and kernel cells, and if I do a kernel run all cells, all these cells should run. It shouldn't stop before we get to running the last cell for your notebooks in general. So you always want to keep your notebooks in a running state. You can also run all the cells by doing this. You don't actually have to restart and clear all the outputs. I usually like to do that just to make certain that things are, I don't have any output from running these cells before I rerun everything. So for me, I can see that yeah, the autograder is correct. If I go down and look at the last cell, it didn't actually run. Right? And it's failing because of my attempt to in the basic sigmoid to not give a type error there. So yeah, I'm not gonna be able to fix that unless I actually give the full solution for the very first one there. So, but that's that's what the very first thing. So if you look at these auto graders, there could be a lot of stuff in here, so it could be a little bit tough to see everything. There's a way to collapse all those. But yeah, if you look at what this does, it will run all the tests that the same ones that are running in the notebook, but it does a few extra things, including trying to make certain that your notebook runs cleanly. So some of the points are always for the autograder, the assignment, or that the notebook is cleanly running every cell from top to bottom. It's not failing halfway through it. So yeah, you'll probably want to check that, make certain that that's working. As well as these. So these, the rest of these should be the same. So again, this is the same as in my notebook. So it's a good idea. So I'm working on the first function for the first task, and I had those 3 unit tests passing, but that one not. That was failing. That's the same as what I saw for the commit that I pushed. So check here. So any questions on that? So there's just some hints about stuff. So so yeah, looking at the rest of these, yeah, question.
So in the mic, looking at, looks like we're still in the glitchy.
Well, yeah, I'm still having some issues with that. So yeah. I'm still working on it. It seems to have some stutter. Yeah, and I'm sorry about the first one as well. So I'll get that worked out. It's annoying because it seems to be working when I tested other places, but then I come here and I'm getting a stutter on the microphone. So I'll test out another mic. I'll keep testing that. Hopefully by the next session I'll have a clean one. Yeah. So yeah, I was just then going to see if anybody wanted to ask a question about any of the others. A lot of this stuff, I mean, we will talk about the loss function. So using like the sigmoid function in various ways, and the and then defining a loss function, and then using the gradient of the loss in order to implement gradient descent. So we'll spend a couple of weeks talking about that at some point. So this is a little bit of some preview. So you're not exactly expected to understand all these yet, but hopefully there's enough information in here to actually implement these, right? So there's actually two functions to do on the 1.1. So the basic sigmoid, and then the sigmoid, the vectorized version. And I don't think I'm giving away too much. Really the only difference is you need to use a vectorized version of the exponential function to get that working. Right? So I will occasionally throw mathematical notation. This course isn't exactly math heavy, but at times I will dip into some things, give a more mathematical presentation or description of how things work. Right? So this is basically this kind of a notation of if I have something that's an array or a vector, that applying the sigmoid function is really just applying that to every value individually in the array. So we're just applying the sigmoid function to the first value in the array, the second value, the nth value, however many values I have. So one reason why sigmoid is used in the gradient descent loss functions is it's very easy to calculate the derivative of the gradient. So you don't really have to know how to derive that, but yeah, the derivative of the sigmoid or the gradient of the sigmoid is really just the original value of sigmoid multiplied by 1 minus that. So given that there, that should tell you how to implement the sigmoid gradient. All these functions should be, well, that's not, these are the ones we've looked at so far are pretty much like 1 or 2 liners, probably. Shouldn't be very complicated. So if you're writing a lot of code for these, you might not be doing them right. Also, another one, if I a reminder here, for the most part, you should be doing stuff using vectorized functions. So if you find yourself writing explicit for loops to calculate the sigmoid, all the values in an array or matrix, or in future assignments you might be more tempted to do this, but you probably aren't doing what's being asked for. So you usually need to write vectorized versions of these. So especially like the sigmoid and the sigmoid gradient, you shouldn't have any for loops in there. You should be using vectorized versions of these to calculate the exponential on the array all at once instead of doing it one by one. So we are going to talk a little bit about feature scaling, about data cleaning. Okay, so starting the week after next, we'll do a little bit of really not machine learning, but just data analytics in general. So the like the second or third chapter of our textbook is really kind of an end-to-end example of doing a data analytics project. So similar to what you're supposed to be doing for the class project at the end here. So some of the first steps you do are do some exploration, but then you might do some some cleaning of features, maybe scaling them so they're all in the same general scale and stuff. So um, a little bit of a side of this, we will see some details of more details of this later on, but this is kind of the standard way that we're going to represent data for machine learning in this kind of two-dimensional form. So each column represents a different feature, and rows represent different samples of our data here. So in this case, we've actually got 4 different features. This task came from I think our textbook, but the columns represent 4 features of a data set. We dropped the label here, so the length, width of the sepal and the length and width of the pedal. And each row then is a different measurement of a different flower. So anyway, for feature scaling, the idea is that we want these scales aren't really too different if we're using the same data that we're shown here, but we test with some different data on this one. But generally, like if I have something that ranges from 0 to 10 for one feature and another feature goes from 0 to 1, that can be a problem for some machine learning algorithms if they have different scales for the features there. Because if one of the features has a much bigger range, that number gets multiplied when you're doing when you're calculating things. So it'll naturally get more important to features that have larger ranges than features that have small. So some algorithms will. So feature scaling becomes necessary for some of the machine learning algorithms, like regression, that we're going to start with. So the idea here is every column, we want to normalize it so it has a mean of 0 and a standard deviation of 1. I think that's what I asked you to do for like a standard scaling here. Okay, I should probably let me know. So yeah, this is a little bit complex. So I don't know if anybody has a question about the broadcasting. But yeah, this is something that we talk a little bit about in the NumPy notebook, if you look through that one. So and again, these are all previous. These will make more sense if you've never run across these. So when we start talking about classification problems, we're going to talk about binary classification and multi-class classification. Or another thing is that sometimes you have features that aren't numerical. So like the features here, it was like a real valued number. So in theory, the length or width of these could have been any length in centimeters or something. How precise you measured it, you could add many decimal places for the measurement. But lots of features or lots of data are categorical in nature. So for this particular problem here, if you read we dropped the label, but there's really 3 different kinds of categories. So if we're trying to do a classification, we would want to output Setosa, versicolor, or virginica. So machine learning algorithms normally can't work with text, so we have to represent that as numbers somehow. So when you have a discrete set of values, so we would normally convert this into like 0, 1, 2, and assign an integer. In this case, there's not an infinite number of different types of flowers, so we only have a small possible set. But if, again, some machine learning algorithms don't work well if you assign categorical like that. So instead, it works better to use a one-hot encoding. So instead, we might, instead of having one feature, which would be the iris type, where we'd have 0, 1, or 2, we would change that into 3 features, where this represents either, if it's, so it's, let's say Setosa, only that column should be 1, everything else should be 0. So that's what a one-hot encoding is. So if it's versicolor, only that column should be 1. So this representation is necessary sometimes for getting better performance than doing this if you're encoding a categorical variable. All right, yeah, so I'm going to, there were 2 more functions, so these are examples of loss functions, although, we're mostly, so the mean absolute error can be useful in some contexts, but will typically be used in the root mean squared error as a loss function. Typo in the so this shouldn't be the absolute value. Yeah, this is the mean absolute error again, just where we've shown that we've taken the prediction. That should have been that again. So again, you don't necessarily have to kind of understand the purpose of this, but basically for like the first one here, you're asked to write a function that evaluates the mean absolute error between the predictions and the true. So you're given basically these. So y hat represents the predictions that some machine learning algorithm made, where y true represents the label. So if we're doing supervised learning, this is how we normally do a loss function like this. So a model is created that makes predictions, and then we evaluate how well it's doing on the model by comparing how close the predictions are to the actual true labels. And so this is one type of loss function. So this is really just the absolute value of the difference between all the summed up. So if you're not familiar with the notation, you just need to use a vectorized version to do a sum, and use a vectorized subtraction. That should give you the absolute error. And the mean squared error is similar, but instead of the absolute value, you square of the differences instead of the absolute value of the differences. And also, yeah, we are asking, I'm pretty certain that we are asking for the root. Because you square it, you can get back to the same range of values by taking the square root after you sum those all up. So often, if we want to have something that makes more sense to us of how big of an error we have for a particular model that we've made, we'll use to take the square root of that mean squared error. All right. Anything else? Let me know if anybody has any questions about stuff, wants to bring anything. So that is due on Friday. So I don't know. I might have said 5 p.m. on some places, but it will be fine. You can use all day Friday, but try to get in, before Friday. I'll probably start working on these sometime Saturday, looking at and evaluating these. In general, you do need to make certain you get things in by the Friday that I asked for them. So I'll often be starting working stuff the next day after that, at least. And do check the pull request. Make certain that you are successfully pushing stuff up there, because I can't see it unless it's right here. And be aware of the auto grader. Be checking that stuff you're seeing when you run your tests and do stuff locally is happening, looking the same when it's run in the GitHub Actions, the GitHub Autograder. All right. Well, let me go ahead and just try and say a few more things. I'm going to switch to something else. Let me go and close this off. And I'm going to open up my class repository. So remember, I already cloned it last time. So I'll just reopen my 574 machine learning repository just so I can get the notebooks. This one, yeah, I can't remember if I fixed the this one. The Python path isn't really important because we usually aren't importing stuff, so it probably doesn't even set the Python path. Use lecture notebook containers here. Oh, shoot. Must have deleted that container. Looks like it's recreating it. So, that run. So as a kind of a final thing here. So yeah, so hopefully, I mean, everybody's also gotten a chance to look at these. I mean, kind of at this point, I'm hoping most people have gotten through looking through kind of Python, either learning the basics of it or reviewing it if you're already familiar with Python, but also probably, like I already mentioned, the NumPy has the most important stuff for this first assignment. In fact, I didn't even ask you to do any plotting or anything, but you'll probably want to read through all these. If you're not familiar with using plotting, using basic matplotlib, pandas and things. So yeah, I was gonna kind of bring up maybe talk a little bit about NumPy. Though it's gonna take a while for that to load here. I did want to mention, maybe kind of just jump down to the time that I have, a little bit more about this concept of vectorization and performance. So, so as this kind of notebook discusses, the main purpose of the NumPy library is providing a high performance array-like or matrix-like object. So the ND array, which stands for n-dimensional array, is the basic data type that NumPy provides, right? So, and it can represent arrays of any dimension. So one-dimensional arrays are typically called vectors in mathematics. Two-dimensional arrays are called matrices, and three and higher, it's becoming common to just call those tensors in general. Or a tensor can mean any n-dimensional array. The other thing to be aware of for NumPy is, these are more like basic arrays that you might be familiar with in C and Java. They're different than like a Python list. Python lists are very high level in that you can put in data of different types in a Python list and other things. an array is meant to hold data all of the same type, and to be of a fixed size. So lists can potentially grow and shrink, but really arrays are supposed to always remain the same size. So both of those having the same data type. So whenever I create an array like this, so in this case the array is two-dimensional. So it's a matrix, a two-dimensional array. We usually call it matrix. All arrays have a shape. So since it's two-dimensional, we have the size of each of the dimensions. And by convention, so we'll usually be using two-dimensional arrays here. So the first dimension represents the number of rows. So we have 3 rows. The second one's number of columns. So two-dimensional matrix of 3 by 5, 3 rows by 5 columns. Two-dimensional matrix here. But all the data is going to be of the same type, right? So both of these, the fixed size and having a single data type, are for performance reasons. So by having those fixed, we can do operations like vectorized operations or matrix operations in high performance ways using like linear algebra libraries and low level highly tuned libraries for doing these sorts of matrix calculations. So yeah, I guess that's gonna take too long. So back to vectorization. The basic idea of that is, so another thing from so we will be using NumPy arrays as well as like pandas data frames a lot in this class. Those will be the basic things that we'll be working with for our assignments and textbooks. So another thing that NumPy arrays give you is you can actually write code that's more like mathematical expressions rather than using lots of loops and things to do calculations. So if I wanted to subtract 10 from each of the values in like a two-dimensional array, in a typical language that's not vectorized, I'd have to write a nested loop. A loop that has an outer that loops over the rows, and then an inner part of the loop that loops over each column. And then for each one of those specific values, so row 0, column 0, subtract 10 from it. Get row 0, column 1, and so on. These vectorized, expressing operations in vectorized ways like this is, I believe, came from MATLAB originally. So that was one of the first languages that I'm aware of that did this. So MATLAB was created specifically for doing mathematical calculations, same as like what NumPy is optimized for. But that's at the most basic of what we mean by a vectorized calculation. And so this is just applying that. So it's legal to apply an operation between an array and a scalar value. So 10 here is a scalar, it's just a single value. But that gets, this is kind of like broadcasting that value. You could also think of that as we broadcast that into a two-dimensional array so that we can subtract each element A from 10 from each of the elements A. And you do the same thing. So any scalar vector is defined on NumPy arrays, multiplication, division, including like raising to a power. Any examples of those? Yeah, so like combining vectorized operations. So I was going to say, if you haven't gotten past the first task here, I mean, it's similar to what we talk about here. Right? So if you have a mathematical expression like this, sine of x squared, so on, the one thing that NumPy arrays vectorization gives you is to be able to express something pretty similar to the mathematical notation. Right? So this directly comes into 50 times sine. So you do need functions, vectorized functions from the NumPy library for doing things like sines, cosines, exponentials, other stuff. The NumPy library has most everything you'd probably need already vectorized for you for doing those. but then other basic operations, powers, multiplication, division, subtraction, but also raising to a power, are also can be applied, will work as expected as a vectorized operation. All right. So yeah, so I kind of went up to the end of the time. I mean, I was going to try and talk a little bit about maybe broadcasting and stuff, but I will leave that. So maybe if we need to, we'll talk about that later. So, but yeah, I'll wrap up for today. To get the assignment in, and then starting next week, we are going to. I might go back and talk a little bit about some of this stuff like plotting things, but we will get in then to the chapter 3 stuff, data exploration things, supposed to be happening next week as well. All right. Yep. That's it. Thank you.